So today we have steps of the scientific method. This is actually your chapter 1, which says what is science. Toward the end of that chapter, there is a few pages on the scientific method. So when your first test comes up, you will be tested on this PowerPoint, steps of the scientific method. And again, those steps can be found at the end of chapter 1. So let's start off with the PowerPoint steps of the scientific method. So the scientific method involves a series of steps that are used to investigate natural occurrences. And so what you want to be aware of is first that there always has to be a problem. Then there's observation. You formulate a hypothesis. You then do experimentation for that hypothesis. You will then collect and analyze your results. And then there is a conclusion. Once you have a conclusion, you communicate the results to your peers. And so this is how the scientific method starts out. In this class, we hope to conduct an experiment that will allow us to see firsthand how this goes, how we have a problem, do an observation of the problem, make a hypothesis, do experiment, collect and analyze results, conclusion, and then communicate the results. So, starting out, a problem or question. Develop a question or problem that can be solved through experimentation. So, once you've done that, then you want to make an observation, do your research on the topic of interest, make a hypothesis. If you remember as a kid, a hypothesis is an educated guess. You want to predict a possible answer to the problem or question. So, for example, this is a hypothesis. It says if soil temperatures rise, then plant growth will increase. Well, if you think about this, a hypothesis should tell you exactly what the experimenter is supposed to do. First of all, it has to be a statement, a period at the end, a concise statement that I can exactly tell what is going to happen. So if I look at this and it said, if soil temperatures rise, then plant growth will increase. So that lets me know that the experimenter wants to do something with soil at different temperatures. So I'm going to assume that he's going to use a high temperature, normal temperature or room temperature, and then a low temperature. And then he'll look to see if plant growth increased at those different temperatures. I would assume that he would do this by measuring using a ruler or a yardstick of some sort, because that would be the data that he would want to collect. So based upon the hypothesis, I can already assume what the experiment will be. So once you have decided on a hypothesis, you have to then develop a procedure, meaning you have to get your recipe together. So it should include a detailed material list, and then you must have outcomes that are quantifiable. As we said, we were going to measure the plants with a ruler, and so that's quantifiable. It have a number to it. So we develop and follow a procedure, have a detailed materials list. We modify the procedure if we need to. Confirm the results by retesting. You always have to test at least 3 times. And then you will include a table, graph, and photographs of your data. As a scientist, you always have to show your data. So as you'll see in your virtual labs, you're always doing a table or a graph, because this is nonverbal representation of the scientific data that you have collected. You then want to come up with a conclusion. This means that you have a statement that accepts or rejects the hypothesis. You always, in your conclusion, have to do this. And then you make recommendations for further studies and possible improvements to the procedure. And then, of course, you have to communicate your results, meaning that you then present it to an audience so that questions can be asked. So now that we have an idea of the scientific method, you do it every day without knowing that you're doing it. When you get up, get ready to rush to work, and go to the car and it doesn't crank up, the first thing you do is say, what's wrong? So you pose a question. You already made the observation, car is not cranking up. The first thing you think is battery. Most people think, okay, the battery is dead. So then you test your hypothesis. Your hypothesis now has become, my battery is dead, therefore the car will not crank or turn over. And so you go get your neighbor, have them give you a jump off, and then the car either cranks or it doesn't. If it does crank, then you can say, okay, I accept my hypothesis. The car did not crank because the battery was dead. If it still doesn't crank after having your car jumped off, then you know that it's something else. And I was taught a long time ago that means it's either the alternator or the starter. But I use that example to point out how you do the scientific method every day and you just may not understand that you are doing it. So let's take a look here at John. Now, I want to point out that you have to pay close attention to this John scenario, because this scenario will come up in on your test, where you have to try and remember how the situation went with John in terms of the scientific method. So he asks his grandmother about baking bread. She explains to him that yeast releases a gas and it feeds on the sugar, and that's what makes the bread rise. Well, yeast does release a gas known as carbon dioxide or CO2. That's why when you take a slice of bread and you see the holes in it, is where the gas bubbles have actually popped during the baking process. So yeast release CO2. That CO2 causes the bread to rise, and the only reason they're releasing gas is because they're eating sugar. All right. So John wonders if the amount of sugar used in the recipe will affect the size of the bread loaf. This is a logical thought, because if yeast eats sugar, make more gas, get bigger bread. That's what John is thinking. So he's on the right track. So let's see what he does after this. So he researches the areas of baking and fermentation and comes up with a test question. He keeps all his information in a journal. Then he formulates a hypothesis. Remember, an educated guess, which has to be a statement. So he says if more sugar is added, then the bread will rise higher. We just said if the yeast eat the sugar, they'll make more gas, meaning that the bread will rise higher because of the gas. So this is John. And based upon this, we can already tell what John's experiment is going to be. If he's going to use more sugar, then the bread will rise higher. That means he's probably going to use different increments of sugar. So let's see what John does. First of all, let's talk about the hypothesis and how, again, it's an educated guess, but it's a relationship between independent and dependent variables. And you all may or may not have heard those terms before. So let's just go over them. How do we know the difference between an independent variable and a dependent variable? So the independent variable or manipulated variable is a factor that intentionally varied by the experimenter. So in this case, what is intentionally John changing? What is he changing throughout his baking experiment? That's right, the sugar. So John wants to actually change the amount of sugar. So the variable that you begin to manipulate or change is considered to be your independent variable. So John is using 25, 50, 100, 250, and 500 grams of sugar in this experiment. The dependent variable, on the other hand, is the factor that may change as a result of changes to the independent variable. Really, it's your outcome. So John is thinking, if I use more sugar, what is the outcome? That I'll get a larger loaf of bread. So the dependent variable is always what is the outcome you're expecting. So in this case, it would be the size of the loaf of bread. His independent variable is if I change the amount of sugar, I should get a larger loaf of bread. And so his dependent variable is what is his outcome, or what is his expected outcome? That he has a larger size loaf of bread. So moving from the independent and dependent variable onto the experiment. Now I do want to backtrack and say we'll take a look at the worksheet for the Simpsons, because that will go along and help us better understand independent and dependent variable. And you need to understand and know those, because that was what you will be tested on for this chapter. Knowing exactly what an independent and dependent variable is, being given a scenario, being able to pick out what was being varied, the independent variable, and what was the outcome, the dependent variable. All right, so back to John. So his teacher comes up with a procedure and a list of materials, and she discussed with John how to determine his control group. So for every experiment, you need a control. It is something you're going to compare your experiment to. It is the normal, what normally happens. So when you're reading a passage and it asks you what's the control, it is what is normal. And we'll see that also in our Simpsons worksheet. Like, what is normal? What is the usual thing that happens? So for this, the control group, of course, as it says, serves as a standard of comparison. So the control group may be a no treatment or an experimental selected group. It has to be exposed to the same conditions as the experimental group, except for the variable being tested. So all experiments, as I said before, should have a control group. Without a control group, then you do not have an experiment. All right. So because John's grandmother gave him this recipe, we're going to use her recipe as a control group. And in her recipe, she used 50 grams of sugar. So John is going to start his baseline saying that, okay, we're going to compare the size of loaf to what 50 grams look like, and then we'll use variant amounts of sugar off of that. And then that will tell us whether or not we increase or decrease the loaf. In any experiment, you have constants. That's where everything stays the same. There's no variation in those. So constants are things like the bread recipe, oven use, time, rise time, ingredients, type of pan, bread rising, oven temperature, age of yeast. All of those things are considered your constant. That means that none of those change from the experiment to the control group. So now moving on to John's experiment. He has everything he needs. He's ready to go. He's done his checklist. And so he decides that he's going to have replicate trials. In science, you always have to have at least 3. And so that's what John does. He then gets all of his data and records it in a table. And this is what we see. Now, if we take a look over here at the control group, we'll see that this is John's grandmother's recipe with 50 grams of sugar. And if we look at the average of the bread loaf, it comes to be about 1260. Well, if we look at 25, 100, 250, and 500, we see that none of the other loaves or different amounts of sugar gives us a loaf any larger than the control group. So now do we accept or reject our hypothesis? Because our hypothesis said the more sugar we use, the larger the loaf. So that meant at 500 grams of sugar, we should have been expecting John to have a large loaf, but he does not. So John examines the data and knows the control worked best, but not significantly better than 100 grams of sugar. So he rejects his hypothesis. But after a rejection, we have to retest. So then John decides to decrease the span or the amount of sugar and go from a range of 500 to 100 instead of from 50, to 100 instead of 25 to 500. So let's take a look and see what he did here. So he carries out his experiments, and this is what we see. The control group, we get a loaf size of 1344. And then if we move on, we see that at 60, we have 1380. And look, at 70, we have 1612, 1332, and 1040. So based upon this experiment, we see that using 70 grams of sugar will yield a larger loaf than the control group of 1344. So this here lets us know that John's hypothesis is, yes, accepted. Because now he has proven that if he teased out the amount of sugar even more, that he could find the exact amount that increased the loaf size. So, as we say, 70 grams of sugar produces the largest loaf. And so now his hypothesis has been accepted. And so in science, this is what we do all the time. We always do triplicates of everything. And then once we have a result, we'll either modify our procedure so that we can look to see exactly um, what is going on. So John tells his grandmother about his project, and they live happily ever after. So from this, you want to take home that the steps of the scientific method. You want to take home what an independent and dependent variable is. That all experiments have an experimental and a control group, and what they are. Control groups are things that don't change. Experimental is the one where you're changing things, and then that you have constants. And then pay close attention because you will see it on your exam questions about John and his experiment, and understanding that he was thinking because yeast fed on sugar that they'll produce more gas and therefore give a larger loaf. All right. So I hope that helps. If you were wondering how does this lecture actually play into your exam in the scientific method.